Okay, so this unfortunately is a bit long, this video, but I really couldn't break it into smaller bits, so just have to be patient. So this one's called parameters of sample proportions. So how does the sample proportion relate to the actual probability of the property? Okay, so it's not, first of all, it's not going to be the same for every sample. It's going to change. Like in a group of 20 people or 30 people, it's not going to be exactly the same. And so what we need to now look at is if we take an average of those sample proportions for over a number of samples, you'd probably get closer to the actual average for the population. Okay, so copy that and come across. Okay, so for instance, here's an example. The probability of having blue eyes is 0.32. In a group of 20 people sampled, the probability of having blue eyes would be the same for each person. Okay, so every person's got a chance of being 0.32. So the question I'm asking is, what sort of distribution is this, where you have blue eyes or you don't have blue eyes? So think about that and pause, and when you're ready, come back. Okay, there were two chances, two types. You either have blue or you don't have blue. And you should remember from your earlier work that this is called a binomial distribution. Binomial distribution, when you either have it or you don't have it. Okay, so copy that and come across. So in binomial distributions, we've got chance of being successful is 0.32, and we had 30 trials. So the expected number of blue eyes would be 0.32 times 20, and that equals 6.4. Now from early work on binomials, the variance, which is a measure of the spread, and the standard deviation, which are connected, the formula is NPQ. And so when we put that into our calculator, we've got 20 times 0.32 times 0.68. And according to my calculator, 4.352. Now, the standard deviation equals the square root of the variance. So we've got 4.352. I'm just going to pause my tape and get my calculator out. Okay, I'm back. It's got my calculator out, and on the calculator it gives you 2.09. So that's the 2 decimal places. Okay. So again, with standard deviations, we can work on what percentage of people would be expected to be within a certain scores. Okay, so that's the first part. Okay, so copy that and come across. Now, we did transformations of these formulas. So for instance, if we had a different expectation of the function, we could multiply by the number and add a constant. Okay, this is straight from last semester's work. And the variance is just a squared times expected value. And this number here doesn't play any part in the variance. Now how we apply that is, so first of all, copy that and come across. So if we've got some other function to do with blue, for instance, 1 over 20, okay, so this new function, this new variable is 1/20th of 6.4, which is 0.32, which is by chance the value of the blue eyes. That's not that critical. So the variance is 1 over 20 squared times 4.352. These numbers came from the previous page, okay, and this number is just a random number, but it is actually to do with the sample size. So when you do that, you get this value here. And I suppose what I want to make note is this one here, okay, was 1/20th squared times NPQ, and N was equal to 20. So we end up with this PQ over 20, which is the same as PQ over N. So that's the important thing there. So I think that's what I got on my next slide. I think so. Just copy that and come across when you're ready. Okay, so I didn't actually have that, but we'll just keep moving on. So for samples that are relatively small compared to the population, basically what we're going to be saying is there's a sample proportion is a binomial variable. Okay, and we'll be doing lots of examples to explain all this. And don't forget that this proportion here is a measure of the success of whatever we're measuring, whether it be blue eyes or people catching a cold, it doesn't matter, but it's a binomial event. Okay, so again, we'll be doing lots of examples to show how this is used. Okay, so we've got these formulas again. You'll just be putting these. So the expected value of p hat is just the proportion, that probability of success. now this variance is now we're going to be using this, okay, PQ over N, and the standard deviation is just the square root of the variance. And on this from here, Q is the same as 1 minus P. So you can use that formula or that formula, it doesn't matter. But just note that the variance is going to be PQ over N for these next ones. Okay, come across when you're ready. Okay, so we got the probability of a car tyre lasting longer than 60,000 is 0.34, okay, and obviously the other event is going to be 0.66. So what is the variance and standard deviation of the proportion, not the number of cars, the proportion of this sample of 30 such cars lasting more than $60,000 K. So here's our sample size here. Okay. So the first thing we do is we write down what we know. We've got P equals 0.34, Q equals 0.66, and the sample size is 30. And so the variance equals PQ over N, which is 3466 over 30. And on my calculator, I get 0.0748. And the standard deviation equals the square root of that number, and that equals 0.865. So that's how you would use these new approaches. Okay, so copy that and come across. Okay, so a coin is tossed 20 times, and the number of heads is seen as recorded, and we're talking about a fair coin. Okay, so it's a fair coin. What is the expected value and the standard deviation of the sample proportion? So we're talking proportions, so it's that's P's and Q's. So what I want you to do is see if you can have a go at this yourself using the formulas on the couple slides ago, and when you're ready, come back live. Okay, we're back. So P is 0.5, Q is 0.5, number of trials was 20. So the expected value of P will be so I just stopped there for a sec. The expected value of the proportion. So we're just looking for the P value. I was going to do the expected. So the expected proportion is 0.5. We're expecting to get 0.5. Just make sure it's written clearly. And then the standard deviation is the square root of 0.5. 0.5 over 20, and on my calculator, that equals 0.1111. 0.11, and that's the answer to that question. So I was going to get the expected number of values, but it was the expected proportion, so it's just 0.5. Okay, come across when you're ready. Okay, each student in a class selects a card from a standard deck 50 times and records how many hearts. Okay, so what would be the mean and standard deviation for the results? Okay, so we'll go through this together. So the probability of success is 0.25, failure is 7.5, the number of trials is 50. So the mean proportion is 0.25. We expect that we're not looking at the expected number of hearts in 50 pulls. It's the expected proportion is 0.25, and the standard deviation equals the square root of 2575 over 50, and on my calculator I get 0.61. Okay, and I think that's it. That's our last slide, and there's the exercise to do. So hopefully you'll enjoy that. Thanks, bye.